Pizza Parlor offers 12 different toppings. Number 1, how many 3-topping pizzas could they put on their menu? Assume double toppings are not allowed. The order in which toppings are applied to a pizza does not affect the type of pizza, which means the order does not matter, and therefore we can answer the question using a combination. For a combination, no item is used more than once, and the order of the items does not matter. So because there are a total of 12 toppings, and the question is how many 3-topping pizzas could they put on the menu, the number of pizzas would be 12, choose 3. And there are 3 common ways to denote a combination. I'm going to go ahead and write 12, choose 3 using this notation here. Let's go ahead and evaluate this by hand. N choose k is equal to n factorial divided by the product of n minus k factorial and k factorial. And therefore 12 choose 3 is equal to 12 factorial divided by the product of 12 minus 3 factorial and 3 factorial, which is equal to 12 factorial divided by the product of 9 factorial and 3 factorial. Let's go ahead and expand 12 factorial until we reach 9 factorial. 12 factorial is equal to 12 times 11 times 10 times 9 factorial. In the denominator, we'll leave 9 factorial as 9 factorial and expand 3 factorial, which is 3 times 2 times 1. And now we simplify. 9 factorial divided by itself simplifies to 1. From here, notice 3 times 2 is equal to 6. 6 and 12 share a common factor of 6. The 6 in the denominator simplifies to 1, and the 12 simplifies to 2, since 12 is equal to 2 times 6. This leaves us with 2 times 11 times 10, which is equal to 220. There are 220 possible 3-topping pizzas. Number 2, how many total pizzas are possible with between 0 and 12 toppings allowed, but no double toppings are allowed? There's a couple ways we can do this. The long way would be to determine 12 choose 0 plus 12 choose 1 plus 12 choose 2 plus 12 choose 3 all the way through 12 choose 12 and then find the sum. But there's actually a faster way to do this by thinking of this a different way. There are 12 total toppings possible, and for each topping, there are 2 choices, yes or no, as to whether to include or not include the topping. So if we think of this as 12 different events with 2 choices for each event, again, yes or no as to whether to include or not include the topping, there will be a total of 2 times 2 times 2 times 2 and so on, total number of pizzas, because there are 2 choices for each of the 12 toppings. And therefore the total number of pizzas with between 0 and 12 toppings is equal to 2 to the 12th, which is equal to 4,096. For number 3, the pizza parlor will list the 12 toppings in 2 equal-sized columns on their menu. How many ways can they arrange the toppings in the left column? Well, first, because there's 2 columns, there are going to be 6 toppings in each of the 2 columns. And if we change the order of the 6 toppings in the left column, it would be different. And therefore, here we have a permutation, where again, for a permutation, no item is used more than once, and the order of the arrangement does matter. And therefore, the number of ways they can arrange the 6 toppings in the left column would be 12 permute 6. Or the permutation of 12 items selected 6 at a time. N permute k is equal to n factorial divided by n minus k factorial, and therefore 12 permute 6 is equal to 12 factorial divided by 12 minus 6 factorial, which is equal to 12 factorial divided by 6 factorial. Let's go and expand 12 factorial until we reach 6 factorial. 12 factorial is equal to 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial, all divided by 6 factorial. 6 factorial divided by itself simplifies to 1. And now we go to the calculator. 12 times 11 times 10 times 9 times 8 times 7 is 665,280. Or we could enter 12 permute 6 by clicking function, the permutation function, main keyboard, 12,6 for the same result. I hope you found this helpful.